Okay, 1.1 day 1, we looked at the parent functions of some common functions. Now we're going to look at transformations of those parent functions. Okay, let's look at transformation versus translation. And let me do translation first, actually. Okay, a translation is when you're sliding a graph or moving a graph or shifting a graph, but it doesn't change the size, shape, or orientation of a graph. Okay, so it can move horizontally or vertically. Horizontally or vertically. Okay, but it's not going to change the size, the shape, or the orientation. It's just sliding it across your paper in different locations. Now, if it's a transformation, it can change. It can change the size. It could change the shape of your graph. It could get skinnier. It could get wider. It could also change the orientation, meaning it could turn it upside down or sideways. Orientation. And it could also move it left or right, up or down, just like a translation. So a translation is a type of transformation, but a transformation can do more than just a translation. Okay, now some of these you have done in Algebra 1. Okay, so for the first one, if you want to translate a graph f of x up k units, I'm going to do f of x. To move it up, I'm moving it in the y direction, so I add k to the end. Okay, so for example, what would this look like? Let's make up a graph. How about if it was cubic? Okay, if it was a cubic graph and it wanted to go up 5, it would go plus 5 at the end. Okay, what if I wanted to go down? I just subtract the number from the end. Okay, so what does that look like in a real number? What should we try this? Let's do absolute value. That might be the absolute value of x. I want to move it down 2 units, minus 2. Okay. Okay, now what if I want to move it right? If I want to move it right, I'm affecting the x coordinates. So it's going to affect the parentheses. Okay, now if I move it right, I actually do x minus something. Okay, when we did parabolas, you might remember this. Okay, so if I were doing a parabola and I was moving it to the right 3 units, it would be y equals, in parentheses, I would say, okay, right 3, and then squared. Okay, how about left? Well, since right is plus, left, or right is minus, left is plus. Okay, so for example, let's go back to cubic again. If it was cubic and I wanted to move it, I would say, okay, I want to move it left 4, x plus 4 in parentheses, cubed, makes it go left 4. Okay, now what if I want to reflect it over the x-axis, which means if it was going like this, I want it to flip down like this. This is my x-axis. I want to change the y values from positive to negative, so I put a negative in front of the graph. Okay, so if I were doing, let's go back to absolute value. If I were doing an absolute value when I wanted to flip over the x-axis, I put a negative in front of the function. Okay, now what if I wanted to reflect over the y-axis? Okay, y-axis is here. So if I want my graph over here to go over here, I change the x value from positive to negative. So it's going to be f, but the x value changes to negative. Okay, and then for example, which one are we on? Squared, it would be y equals, I want the x to change to negative, and then I would still square it. Okay. Okay, for the first example, we're just going to look at it and identify the transformation of f of x so we get used to looking at it. Then we're going to regraph the function as well. Okay, this is g of x equals f of x minus 4. So I'm taking f of x and I'm moving it down 4. So the transformation is it goes down 4 or it translates down 4. Okay, now f of x is actually this graph right here. So I want to regraph this down 4. Depending on your visual skills, you would do this differently. I'm going to start with the easy points. I'm going to take this down 4. 1, 2, 3, 4. Okay, let's do this end point over here. This one. 1, 2, 3, 4. About the same spot. Okay, and then what? 1, 2, 3, 4. And it goes here. So this is a arrow. This goes here, and this is a curve over, something like that. Just a sketch. Oh, that looks smushy. Hold on. Okay, something like that. It should look like the same exact graph shifted down 4. And depending on your skills at visualizing, you might do it differently. Okay, let's, for b, it says g of x equals f of x plus 2. Okay, it's in parentheses, so it's either left or right. If it's plus, it's actually left. It's because if I do a -2, it makes it go back to 0. So this is going to go left 2. So I'm going to take this graph of f of x and shift it left 2. Okay, and however you would like to do that is fine. Left 2, left 2, and it's just a sketch. See, this goes down, and then this makes like a little hoopy hoop. Okay, it should look like the same exact function transform left 2, and it didn't change shape or position. Okay, now let's look at C. Okay, what's the difference? It has a negative in the front. If it's in the front, it's changing the y values. If it's changing the y values are going from positive to negative. So that's going to reflect over the x-axis. Okay, what does that mean? Okay, well, the x-axis is this guy right here. So I'm going to take all the points and flip them across. So this point here is 1 up, now it's going to be 1 down. Okay, what about this one? This point is 1, 2, 3 up, now it's going to be 1, 2, 3 down. Okay, let me connect that. Kind of see it coming. There we go. Okay, now what about this weird curvy guy? Well, he's a half circle. How far does he go? He goes to 4. So I'm going to take him to -4. So something like this. Okay, now if I look at this, this is the same graph, but it's flipped over the x-axis or reflected over the x-axis. It did change orientation, so this is a transformation. Okay, one more. Okay, what's changing on this thing? Well, the x is changing to negative. So the x was positive, now it's going to negative. It's going left, right, left, right. So that's flipping over the y-axis. This one right here. We call that reflecting though. Reflect over the y-axis or about the y-axis or reflect something about the y-axis. And it is weird. When the x changes signs, it means y-axis. Okay, so what does that mean? Well, it means that this thing's got to be over here, and this thing's got to be over here. So let me start with this thing. So this little guy goes here. Instead of being left 2, it's right 2. And it goes that way, and then there's an arrow over here. Weird, right? Okay, now this little semicircle has got to be over here. So something like that. Okay. Okay, now example 1, we were working with a random function that was given and graphed. Okay, but we're often working with a parent function, and the parent function tells us the shape, and then what we know about transformations tells us where to move it and how to move it. Okay, so let's look at these. First, we're going to identify the parent function, then we're going to identify the transformation. So, parent functions, linear, quadratic, absolute value, cubic. Okay, so this is x minus 2. This is squared. Since it's squared, quadratic. If I were to graph it, I know it's going to be a parabola. Now, what are the transformations? Well, I see parentheses first off. X minus 2, right 2. Plus 5, up 5. Okay, if you feel good, go ahead and pause it and then check your answers. If you're not, let's look at this next one. Okay, let's first see parent function. F of x equals x plus 5 cubed, cubic. Now what are we doing to it? I see x plus 5. Is that left or right? Left 5. Translates left 5. And then what? Down 13. Okay, parent function for C. Negative absolute value. Right when I see absolute value, absolute value. Okay, now what do I see first? I see a negative sign, and we're going to do the reflections first. So reflect. Since it's in front, it's going to reflect the x-axis. Okay, but what else happens? Okay, inside the bars are kind of like parentheses. It says x plus 4. Is that left or right? Left 4. Okay, one more. G of x equals the absolute value. Just pause. I already know the parent function is absolute value. Okay, reflection, yes. What is changing? The x is changing signs to negative. If the x is changing signs, it's reflecting the y-axis. About the y-axis, over the y-axis. Let's say over. Reflect over y-axis. They often say about though. Okay, and then what do we have? Then we have the plus 2 at the end, which means it's going up 2. Okay, and you do want to say it reflects it and then it moves it up. Because it will change the graph if you do it in a different direction. So reflect, then move it. Okay, now we're going to use what we know about parent functions and transformations to write the equation for the given function. Okay, now it doesn't say what to call our equation. So we could say y equals, we could say f of x equals, it's up to you, but we're going to start there. Okay, what is shape is this graph? It's a parabola. So I already know it's quadratic. Should I make notes? Let's make notes. I know it's quadratic. Okay, now do I know how it is transforming? It looks like it's normally here, so it went up 3. So it's quadratic and it went up 3. So what's my equation? Quadratic up 3. Okay, let's try it again. It's gonna get harder. Okay, let me just start with y equals. F of x equals is a great one too. Okay, now shape. Parabola. It's quadratic again. There's going to be a squared in it. Okay, now there's a lot of stuff going on in this one, so let's see the first thing. What's the first thing weird? It's opening down. If it's opening down, it reflected the y-axis. So since it opens down, what goes on the equation? Negative. Okay, now what? Does it move left or right? It does. Which way? It moves 1, 2, 3. Left 1. Left. No, not left 1. Left 3. What does that look like? Parentheses. Left 3. What is this? Quadratic. Okay, does it move up or down? Left 3, down 1. It goes down 1. Down 1. Okay, let's check it. Okay, it opened down. Yes. It went left 3, down 1. Left 3, down 1. It was quadratic, has a squared. Okay, let's try next one. What is this? Absolute value. Start with y equals though. Okay, does it open up? Doesn't open down, so we're good. Does it move right or left? It moves right 3. So in parentheses, I do right 3, but this is absolute value. So absolute value x minus 3, right 3. Does it go up or down? Sure, it goes up 2. Up 2. So it's absolute value, right 3, up 2. Okay, one more. Y equals, what is this thing? Absolute value again. Because of the v. It opens down. What do we do? Put a negative in the front. Okay, let's see which way it moves. It goes left. 1, 2, 3, 4. It goes left 4. Okay, so in parentheses I do x plus 4, but this is absolute value. So in absolute value I do x plus 4. Okay, now does it go up, down? No. So it opens down, goes left 4. Done. If you want to put plus 0 at the end, you can. Okay, now they're going to give you the equation. Let's try to graph these. Okay, let's look at this one. Y equals the absolute value of x plus 2. What do I already know? Absolute value of x. What's absolute value? It's a v. What else do I know? Up 2. So this is going to go up 2. Since its absolute value makes a V, the slope of the V is 1 unless otherwise indicated. So I'm going to go up 1, right 1, and make a perfect V. On this other side, up 1, left 1. So it's absolute value, and it went up 2. Arrows are nice. Okay, let's look at the next one. Okay, what is the parent function? Absolute value. What does that tell me? It's going to make a V. Okay, what else do we know? This thing, left 3. So left 3, 1, 2, 3. Absolute value makes a V. Should be going through the corners unless otherwise indicated. There we go. Okay, let's look at one more. What's the parent function? Absolute value. Shape, V. Okay, let's look at it. Oh, it's got a negative, actually. So instead of a right side up V, upside down V. Okay, what else do we know? Goes right 1. What else? Up 4. And then what do we do at the beginning? We've reflected over x-axis. Okay, so let's go right 1, up 4. 1, 2, 3, 4. And it's going to open in the downward direction, but it's a V, so it should still be hitting the corners. Okay, now there's one more type of transformation. It's called a vertical stretch or shrink. Okay, a vertical stretch or shrink occurs when there's a coefficient in front of your parent function. So something like 2x squared, or 2 times the absolute value of x, or 2 times x cubed. Okay, when the value in front is greater than 1, or the absolute value is greater than 1, it's a stretch. So for example, if I did y equals 4x squared, stretch. It could be -2. If it was like -3 absolute value of x, that's still a stretch. Okay, it's a shrink if the a value, the absolute value of a is less than 1. So if I do y equals like 1/2 x cubed, that's going to shrink it because it's less than 1. It could be -2, and it could be a decimal. Let's do a decimal. How about y equals -0.8 x squared? That's still shrinking it because 0.8 is less than 1. Okay, let's just identify the transformations. Okay, what is this? The parent is absolute value. What am I doing to it? I'm timesing it by 2. If you times it by 2, is it getting bigger or smaller? Bigger. Stretch. Vertical stretch. By 2. How about this one? Y equals 1/2 x squared. Parent function, quadratic, x squared. What am I doing? I'm timesing it by half. Does that make it bigger or smaller? Smaller. So this is a shrink. How much am I shrinking? Half. Okay, what's going on with C? A lot of stuff is going on with C. Okay, what's the parent function? It's cubic. The cubic is just the parent. Okay, we are going to start with the stretch or the reflection when we're doing the multiplication first because that's the order of operations. So it's getting times by 4. What does that mean? Vertical stretch by 4. Okay, what else is happening? Right 1. Anything else? Yep, down 5. Okay, and do the stretch or the reflections first. Okay, y equals -4/5. Absolute value of x plus 7. Parent function, absolute value. Okay, so that's my parent. Okay, what are we doing to it? Oh, we're doing so much. Okay, well, there's a negative. So what does negative mean? Reflect x-axis over x-axis. What else? We're timesing by 4/5. Is that a stretch or a shrink? Since it's smaller than 1, because 5/5 is 1, this is a shrink. So vertical shrink. Okay, and then you do the reflections and the shrinks first. Anything else? Oh yeah, the plus 7. So up 7. Okay, y equals negative 2x squared minus 3. Parent function. It's a quadratic because of the x squared. So it's just, what are we doing to the x squared? Okay, first thing, there's a negative. Reflect over x-axis because the negative's in the front. Okay, what else? Oh, there's we're timesing 2. Stretch or shrink? Stretch. Okay, anything else? Yup, down 3. Okay, one more. Y equals negative parentheses x plus 1 cubed. Parent function. Cubic. Okay, so what are we doing to the cubic? First thing, negative. Reflect. I'm going to say over x-axis, but they often say about x-axis or of the x-axis. Okay, what else? X plus 1 in parentheses, left 1. And then what? It's cubic. Done.